Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous video we have seen the example and definition of context-free language. Now onward we will be trying to generate context-free grammars for certain very common languages. Let us start with our very first example. Over here we are coming with the most discussed example, a to the power n, b to the power n, which we already discussed at the time of pumping lemma, even at the time of regular languages. Let us try to write a context-free grammar for this language. Here you can see that we need to generate a b along with every a. What are the type of strings in this language? The smallest string possible over here is epsilon. Then comes ab. Then comes 2 A's followed by 2 B's. Then come 3 A's followed by 3 B's. And so on. So we know that we have to generate a B along with every A. Let us say S is our start symbol. A is B is the production. You can see that every time you use the production, along with an A, B is generated. Now, if I need to generate the empty string, I need one more production rule. That means I will be adding one more production rule that S will produce epsilon. This grammar produces exactly the same language that we have written in this particular bracket. You can see that this will produce epsilon because S produces epsilon. Now, other than epsilon, it will produce equal number of A's and B's, that is of the form a to the power n, b to the power n. Now, let us derive a few strings from this particular grammar using various methods such as a left-hand side derivation or a rightmost derivation or a parse tree. Let us select our string. Let us say the string that we are going to generate is 3 A's followed by 3 B's. The first thing that we are going to do is leftmost derivation. We will start with our start symbol. We need 3 A's and 3 B's, so we will use the first production. We have generated 1 A and 1 B. Let us use the production again so that we can generate more and more A's and B's, as we need 3 A's and B's. Now you can see that I have already generated 3 A's and 3 B's. Now we will not need the start symbol S anymore. We will use the production epsilon for replacing S. You can see that now I got the expected string 3 A's followed by 3 B's. Here I have written leftmost derivation. Even if we are using a rightmost derivation, you will see that similar string is derived because we have only one non-terminal over here, that is S. So over here I am writing the rightmost derivation is same as the leftmost derivation. Now let us see the third form, that is drawing a parse tree. In the parse tree, the root will be the start symbol, that is S. In the first step, you will see that we are using the first production. We will need the production once again. Now we have generated 2 A's and 2 B's. We will need the production once again. Now we have completed the generation of the parse tree so that we can remove the start symbol S now by epsilon. How do we recognize the string generated by this parse tree? We have to traverse the tree. Which traversal we will be using? We will be using a pre-order traversal. In a pre-order traversal, we will start with this S, then comes this A. So the first alphabet generated is A. We will go back. You will approach the second A. Similarly, we will have a pre-order traversal further. You will reach at the third A. We are using epsilon. We are traversing back now. We have encountered the first B, the second B, the third B, and we reach back at the start symbol. You can see that the yield of this parse tree is the string that was required, triple A followed by triple B's. You can say that the grammar that we have constructed successfully generate the language which was required, that is A to the power n, B to the power n, such that n is greater than or equal to 0. From the next video, we will be seeing few more questions of constructing context-free languages. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.